Section 4.4. Okay, so today is a lot different. This section is different than 4.2 and 4.3 in that we're actually solving. Oh, wait, I'm going to get to Jenna's questions first. Let's do 4.3. Jenna asked, can you go over 7, 23, and 29? Let me see if I can. Hopefully I can, Jenna. So 4.3, number 7. We've got log base 7. This is number 7. 7 over x. Okay, so the first thing I notice on this question is division. So I've got to do the log base 7 of 7 minus log base 7 of x. And then I'm going to look at both of these and say, okay, can I simplify them? The log base 7 of 7, that was one of those basic rules from 4.2 that said this was just a 1. Minus, I can't do anything with that second one because the bases don't match up. 7 and x are two different numbers. Does that help for that one, Jenna? Okay. And then 23 is log base 4. Now look, before I even get going, I'm going to write the square root of x as x to the 1/2. Because we can't simplify that thing if we think of it in square roots. So just like before, I'm going to separate them. Log base 4 of 1/2 minus log base 4 of 64, okay? And then the log base 4 of x to the 1/2, this 1/2 I could bring out to the front. I think that was called like the power rule of logarithms. That was in 4.3. Log base 4 of x, kind of goofed up there. That's 1/2 log base 4 of x. Minus, now, I need to think, can I get 64 into a base 4? I can. It's 4 to the 3rd power. And if you're like, I don't know that. Well, I'm telling you, just take the calculator up and go, whatever your base is. You can go, okay, I know 4 times, there's a super glare going on. 4 times 4 is 16. That's not going to work. Times 4, oh, that's 64. So 4 times 4 times 4 is 64. Therefore, it is 4 cubed. And then that'll simplify like this first one in a way. I'm using those rules from section 4.2. Okay? And then 27. Okay, that's a good one. So let's do 27 now. 27 says log base b of x squared y over z squared. Now it's a base b. None of these are going to simplify with base b. 29. Okay, yeah. 29 says log of, now again, I'm going to write this as 100x to the 1/2. Okay? 100x to the 1/2. Let me put my phone on silent. There we go. Okay. Because the square root is just raised to the 1/2. So from the very beginning, I'm going to bring this 1/2 out front. So log of 100x. And now look, this is multiplication, so I can split this up with multiplication. I got to be careful. This 1/2 has to be multiplied to both terms. So log of 100 plus log of x. That's just splitting up this logarithm. Now this 1/2 is multiplied to everything. So it's got to be multiplied to everything once you split it. Now, log of 100, you can pop that in your calculator. It's just 2 because 100 is 10 squared. And it's log base 10 of 10 squared plus log of x. Now, I don't know if they left it here or they multiplied it through. So if they multiplied it back through, you'd get 1 plus 1/2 log x. And I don't have the answer right in front of me, Jenna. But hopefully that helped. Yeah, that one's not too easy. Okay. Does that help? Hopefully, a little bit. Okay. Do you guys have any other questions from 4.2 or 4.3? I don't mind going over any of them. We'll see 4.4. I'm not going to say it's easier. That's not really the right way to think of it, but it's solving. So we can check it easier. We'll actually get like x equals 4 or x equals 10, where here we've got this crazy stuff going on and we're simplifying it down, which tends to be the harder parts of the logarithmic sections. Okay, cool. So let's look at solving now. So let's get into 4.4. And 4.4 does have my favorite picture in all of the Blitzer books. If you look at page 479, it is a elderly couple having a good freaking time on a jet ski. And hopefully one day, once I can retire, it's going to be me, my wife, having a good time on a jet ski. But anyway, let's look at this first. Actually, your book first goes over solving exponential equations. And there's two ways to do this. So first we're going to solve exponential equations. So with exponential equations, there are two ways. I'm going to go over the first way, which only works for very special situations. The second way I'm going to go over works no matter what, but it's quicker to do this first way if we can get it to work. So the goal here for the first way of solving these is to get the bases to be the same on both sides of the equation. Look, if we know b raised to the m power equals b raised to the n power, then m must equal n, right? If b to the m equals b to the n, then m must equal n. That's the rule we're going to use. So a very basic example would be like 2 to the x. Let's do one that we actually have to solve that one. Minus 16 equals 0. Okay, so I'm going to show you this with an example and go over the steps with an example. Step one, you're going to isolate the exponential term, or if we have two exponential terms, you want to kind of separate it. What I mean by that is, for this example, that's our exponential term. So we're going to move that 16 over. So 2 to the x equals 16. Now the goal is so that's step one. Step two, the goal is going to be to get that term that's not an exponential into the same base. Because if we can get the bases the same, we can set the exponents equal to each other. Well, 16 can be written in a base 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So 16 is just 2 to the 4th power, okay? Now, once we have the same base, we can set the exponents equal to each other. Well, this just winds up being x equals 4. Now, sometimes you have to solve that out, okay? If it was, I'll give you an example here in the next one where this takes a few more steps. But this is a good basic example. You got to get the exponent by itself, and then get the bases the same, and then set the exponents equal to each other. And I know what you're thinking. What if I can't get the bases equal the same? Well, that's going to be the other form of solving we'll get to, okay? And what's nice, this is equations. We've got a solution. We can check it, right? Okay, I'll use a different color for checking it. So this is just me checking. So if I plug in x equals 4, I got to go to the original equation. And I want to see, does 2 to the 4th minus 16 equals 0? Yeah, 2 to the 4th is 16. Minus 16, that equals 0. So I know this has to be my solution. That's what's nice about equations, right? In 4.2 and 4.3, we couldn't really do that. We were just simplifying. But in 4.4, we can actually check our answer, which is real nice. Okay. Questions other than, I kind of need to see that a few more times. Okay. I'm going to give you one to work. That's not too bad. And then I want you to check it to make sure you're right. So let's say we had 5 to the x plus 4 equals 25. Okay, try that one. I'll give you just a minute. If you don't get it right, that's fine. If you have no idea where to start, that's fine too. We'll go over it. So here's what we need to do. First off, we already have the equation, the exponent. I'm going to put parentheses right there, actually. We've already got the exponent by itself, the exponential term, I guess you can say, by itself. So I need to see if I can get 25 into a base 5. And I can, right? 25 is just 5 squared. And because now I have the bases the same, I can set the exponents equal to each other. X plus 2 equals, or X plus 4 equals 2. Solve it out. And I wind up with X equals negative 2. Okay? But then I'm going to check it. So I'm going to plug negative 2 into the original equation. So this is me checking. 5 to the negative 2 plus 4. I want to know, is that equal to 25, right? Well, negative 2 plus 4 is 2. Yeah, 5 squared is 25. That checks out. We have our solution. Okay? Questions, comments, concerns? Okay, let me find some that maybe look a little weirder. Okay, let's say we've got ooh, that was really weird. We're actually gonna solve a lot of these with the other way of solving. Because if it unless it's very clear to see that the bases line up, it's not that efficient to use this method. Okay, but let's do one that is that maybe we have to work a little harder at. Let's say I've got. I'm stealing one from the book here. Oh yeah. Oh, what does it mean? This is number 14. 5 to the 2 minus x equals 1 over 125. Okay, I'm going to give you a minute. I want you to try this one because you can get 1 over 125 into a base 5. So I'm going to give you a minute. And I want you to try this one. It's kicked up a little bit. And we'll go over it. Of course, if it's just doesn't make any sense. Okay. Okay, let's see here. We've got to see if we can get 125, 1 over 125 to the numerator, which we can. If you've been working on the last homework, you'll see we've manipulated these exponential equations a few different ways. But I know that 125 is 5 cubed, 5 times 5 times 5. And then if I want to bring it to the numerator, I have to make it negative. So it turns out 1 over 125 is just 5 to the negative 3. Okay, 125 is 5 cubed. So I bring it to the numerator, I've got to make it negative. Okay, now look, I've got the same base. Now I can set each one of those equal to each other. 2 minus x equals negative 3, right? Pretty cool. Now I've got to solve for x. So subtract the 2. I end up with x equals negative 5, or negative x equals negative 5. I need to get the negative to go away. So 1. I get x equals 5. But now I have to check it, right? I got to check it. So I'm going to plug x equals 5 into the original equation up here. So this is me checking. 5 times 2 minus 5. I want to know, is that equal to 1 over 125? That would be 5 to the negative 3. Is that equal to 1 over 125? Now, I know that's true, but if you wanted to check it in your calculator, there's a nice fraction button in here. So if you hit 5 raised to the negative 3, and then, so 5 raised to the negative 3, and then if you hit the math button, the very first option is frac. This will give you your answer as a fraction. 1 over 125. Hey, I know that that's the right solution now. Okay? Yeah, if you want to write that down, it's math frac. So if you hit math, the math button, and then frac, it'll give you the answer as an equate or as a fraction, which is nice. Okay, that can help. Questions? I'll give you a minute to kind of recoup on your thoughts here, kind of bring them together. Okay. So now let's get to, well, what happens if you can't get them in the same base? Or what if it's just like really flipping hard to get them into a same base? Well, that's when we can use common logarithms. We're going to use ln. And I'm going to make sure to kind of follow the directions in your book because sometimes this is solved there's a few different ways to kind of notate it with different books. So I want to be consistent with your book. Your book starts with like a basic example. Let's say we've got 4 to the x equals 15. Okay? 4 to the x equals 15. So we cannot get 4 or 15 into the same base. It's just not possible. 15 cannot be written as a base 4. Okay? But how can we solve it? Well, we're going to start it the same way. You have to have the exponential term by itself. Okay? You got to have the exponential term by itself. And equals a number. Now, we haven't done one with exponentials on both sides. We'll get to one like that here in a second. But we have to have an exponential equals a term or exponential equals an exponential. And then once we have that, we can actually take the natural log of both sides. I'm going to use ln, okay? So we can take the ln of both sides. Okay? So take the ln of both sides. Once we have that, we take the ln of both sides. And what's neat is we can use a rule that we learned in the last section that said if we have an exponent inside a logarithm, we can bring it out to the front. So this becomes x ln 4 equals ln 15. Okay? X ln 4 equals ln 15. Now, to solve for x, you just divide off the ln 4. So we wind up with x equals ln of 15 over the ln of 4. Now, look, you remember with the change of base rule, you can write this as a logarithm. Now we're going to kind of go backwards with the change of base rule. If we already have the ln over the ln, this would be equal to log base 4 of 15. Now you're going to see in your book and on the test, it might give you the answer like this, or it might ask you for an approximation. So I'm going to put this in the calculator. To put in the calculator, I've got to put it like this: the ln of 15 divided by the ln of 4. Let's do 4 decimal places. 1.9534. Okay. So it might ask for, it's going to ask for one of them. Okay, but just be careful. This can be answered in 3 different ways. So if you check the answer in the back and it's not what you say, you answered it this way, but then it's a logarithm, just put it into a logarithm. Remember, log base 4 of 15, if I wanted to use a change of base rule, what's ln of 15 over ln of 4? Okay, we have to know how to go back and forth on that. Now, it also might ask for the approximation, right? And so it's just right there. Now, I'm going to use the approximation to check it, because this is an equation. I can check it. I'm going to put in 4 raised to the 1.9534. And now look, we rounded. So I'm going to put, it should be close to 15. Should be close to 15. Let's check it. 4 raised to the 1.9534. Oh, yep. That's pretty close to 15. 14.99999. That checks out. That gets to be correct. Okay. Any questions? So look, you got to have the exponentials on both sides, or I'm sorry, either the exponentials on both sides or an exponential equals a term. And then you take the ln, and then we use that rule that says, hey, if you've got an exponent inside a logarithm, you can bring that exponent out to the front. then I'm going to divide away whatever's not x, right? Or whatever I can. We'll see. These are going to get more complicated. Okay. This is a very basic example. I'm going to give you one that's a basic example, and I want you to try it. And then we're going to build on top of this kind of basic idea of solving. Okay. So I want you to try this one. It's going to be very similar. I'm going to steal it straight from the book. Let's say we had. Oh yeah, this one you might wind up with an actual number for this one. This is number 4. 5 to the x. Actually, I'm going to change it up a little bit. 5 to the x minus 625 equals 0. So this is number 4. And I want you to solve it the way we just did. Okay. So the first thing I'm going to do is I'm going to move this 625 over. And then I want you to solve it the way we just solved it. Okay. The way we just solved it. I'll give you just a minute, just so we can get this pattern down. Okay, let's see. Now, if you're not done, that's fine. We're going to just keep on chugging along here. So I'm going to take the ln of both sides because I have an exponent equals a number. And then the rule says I can bring the x out front. So x times ln of 5 equals ln of 625. Divide the ln away. So I'm left with my x value. So x equals, now it might equal this. If I want to write it as a logarithm, it's going to be log base 5 of 625. Now I'm going to pop this in the calculator because if it's a number, which it's about to be, a nice integer, we're going to use that as the answer. So ln of 625 divided by ln of 5. Oh, that turns out to be 4. Cool. What that meant was 565 or 625 here was actually 5 to the 4th power. So it would have been a lot easier if I'd noticed that at the beginning. Hold on one second, Chastity. If I noticed this from the very beginning, it would have been a lot easier to say, oh, 625 is just 5 to the 4th, x equals 4, and I'm done. But I wanted to show you this because if you don't see that, you can use this form of solving to get to the right solution. Okay, what's up, Chastity?
You just answered my question.
Okay, yeah, no problem.
I did not see what you were trying to do there.
Yes.
I do now.
Okay, gotcha. Okay, let's look at just different forms and how this can pop up. And really, we're using the same process. It's just gonna look a little different. Let me steal some here. Oh yeah, this one looks horrible. Hold on, let's see if there's an easier one. No, that's fine. This is number 20. Number 20. Oh, use pink because this one looks rough. 8 raised to the 1 minus x equals 4 raised to the x plus 2. Now, right off the bat, I'm going to put parentheses around exponents just so you can clearly see it's in the exponent. And I'm going to tell you, sit tight. This is going to take a little bit of time to solve, okay? And watch me. I'm going to try to go as slow as I can because this is the type of question I get the most emails about. on this section. You know, oh, can you please go over this one again? I don't get it. And I understand it's not easy. Okay, so now notice both of these have an x in the exponent. That's fine because we have a single term equals a single term. So we're fine. We're just going to go ahead and take the ln of both sides. I know it looks different, but that's not a big deal. Okay, so ln of this equals ln of that. Okay. Now look, we're going to do this same thing we did before. Look, this whole exponent here is inside the logarithm. So the whole thing is going to come out front. So I'm going to make sure to keep this in parentheses. 1 minus x, right? That was the exponent here, times ln of 8 equals x plus 2 ln of 4. Okay? We brought the exponents out to the front. Okay. So now we have to think about what to do. Well, you know, kind of the way to solve these is to get rid of the parentheses first, right? So we're going to get rid of the parentheses. I've got to distribute this ln 8 to both terms in here, and I've got to distribute this ln 4 to both terms. So look, 1 times anything is itself minus. Now I can't multiply these necessarily, but I'm just going to make the x the coefficient. So it's going to be x times ln 8. Okay, really minus x times ln 8. Distribute the ln 4, so I get x times ln 4 plus 2 times ln 4. Okay? So 2 times ln 4. So all I did was take the ln 8, distribute it to both terms, 1 times ln 8, minus x, well, that's just negative x times ln 8. Same thing here, ln 4 times x, and then 2 ln 4. Okay. Okay, well, it doesn't look like we're any closer to solving these. Okay, the next thing would be, remember back when you were learning to solve equations? I'm talking like at the very beginning. The rule that your 3rd or 4th grade teacher, or maybe 5th grade or 6th grade teacher taught you was get x's on one side and get numbers on the other, right? I mean, that's kind of the golden rule when solving for variables. So what we're going to do is exactly that. Notice, okay, here's what I mean by that. If it has an x, we're going to get it on one side, and if it doesn't have an x, we're going to put it on the other side. Okay, so I'm going to bring all my x's to the left. So what I'm going to do is I'm going to move this x ln 4 to the left. So I'm going to subtract x ln 4 over here, ln 4. But then I'm going to move this ln 8 to the other side. So I'm going to subtract ln 8 to the other side. So what I've done is if it has an x, it's on the left-hand side now. We're left with negative x ln 8 minus x ln 4, right? That's these two terms. And then this ln 8 I moved to the other side. So it equals, now the ln 4 was already there. So, I'm sorry. The 2 ln 4 was already there. So 2 ln 4 minus ln 8. Okay? So nothing too weird, but it looks goofy because we've got like x's and ln's. But now here's the key part that whenever I have students come ask me about this question that they forget is if we have x's in both these terms, we can factor an x out. And do you see how all I did was factor the x out? There's an x in both terms. It's a factor in both terms. So I can factor it out. And then I'm going to divide the negative ln 8 minus ln 4 on both sides. Holy cow, that could be our solution, okay? And that looks crazy, but that's what x equals. All of this goes away, right? And you're left with x, okay? Oh, this one was kicked up a lot of notches, okay? A lot of notches. We're going to do some way after this that are easier than this. But let's put this in the calculator. Maybe it turns out to be a nice number, okay? So let's see here. Ooh. If I can get my calculator on, there we go. I'm going to do a parentheses of the numerator, 2 ln 4 minus ln 8. So close that parentheses for the whole numerator. Divided by, open up another set for the denominator, negative ln 8 minus ln 4. Close that set, hit enter. It equals negative 0.2. Is that right? What number was it? I stole this one from the book. Yeah, it is right. And now if you're like, hey, the answer's in a fraction, all you have to do is hit math fraction. And it'll give you it'll give it to you as a fraction. So math fraction, negative 1/5. And just trust me here. I don't want to go back and to check this one. I'll be a little lazy. Okay. But that's the answer. Okay, that's fine, Lauren. Make sure to watch the rest of this video, though. It's not that it gets easier or harder. It's just a lot of curveballs are about to be thrown at us. Look, this is not easy. I don't expect you to know this from the get-go. I just want to make sure that you've seen it, so that way when you get to these questions, you can kind of go back and use this as a reference on how to help solve them. Okay. I mean, you guys haven't done the homework for the easy ones yet. You got me? So don't be too upset if this one's not clicking. Okay. Don't be too upset if this one's not clicking. Okay, yeah, let me do one with e's. Man, it's nice when you see e's. Okay. What I mean by that is we know that ln and e cancel each other out. So let me steal one from the book. Oh, let's say this is number 32. 4 e to the 7x equals 10,273. Okay. 4e to the 7x equals 10,273. Now, I'm going to start this the same way. Now, oh, good, we haven't seen one like this. Notice there's a coefficient of 4 here. We need to get this by itself. We need to get that exponential term by itself. So the first thing we need to do for this one is divide both sides by 4. Okay, this isn't going to be a nice number. I'm going to leave it, I guess, as a decimal because it won't be a crazy decimal. 10,273 divided by 4. 2,568.25. Okay, I'll leave it as a decimal. Let's see what the book says. So solving, this is number 32. Yeah, 32. Solve each exponential equation, express the solution set in terms of natural logarithms or common logarithms, then use a calculator to obtain a decimal approximation. Okay, that's fine. So at this point, we're going to take the ln of both sides. And what's neat about e's is that the ln and e cancel each other out. Remember, ln is just log base e. So therefore, it's going to cancel. And leave us with the 7x. Okay. And then I'm going to divide both sides by 7. Now, look, you can't divide this into that ln because you've got to take the ln first. Okay. It's kind of like an order of operations thing. So we can't say that it's ln of whatever this divided by 7 is. No, these are two different numbers. Okay. So we're going to say one of the answers is ln of 2568.25 divided by 7. And then I'm going to pop that in the calculator. Make sure to close my parentheses in my numerator. So 2568.25. Close that parentheses, right? You see that? Close that parentheses. And then divide it by 7. And I wind up with, now your book says, I think, to round to 2 decimal places. Yeah, 2 decimal places. So 1.12. Okay, 1.12. And now I'm going to check it because this one won't be too bad to check. So I'm going to go back to the original equation and I'm going to just put in the calculator 4e to the 7 times 1.12. I want to see if it's close to 10,273. So 4, where's my e button? It's e 7 times 1.12. See, I'm gonna use more decimals to check my answer. And that's purely what's going on here. what was the 1.2156857? Yeah, there we go. Notice this is much closer. Once we added more decimal places, here, I'm going to zoom in there. Once we added more decimal places, we got much closer to the actual approximation there, the 10,273. So I would do that. If I'm going to check my answer, I'm going to put more decimal places in to check my answer, okay? But I know this is right because I checked it, okay? That one wasn't too bad to check. Questions? I'm going to give you one of these to try because they're not that bad. Remember, the ln and the e cancel. That's why I want to give it to you. I got to get some more paper here in a second. Let's say I've got, let's say I've got 200 e to the 0.023x equals 600. So I want you to try that one. So I want you to solve for x, try that one. I'll give you a little bit of time. Okay, let's do this. So first thing, just like before, I've got to get that number out of the way. I got to get that coefficient out if I can. This becomes e to the 0.023x equals 3, right? 600 divided by 200 is just 3. So now I'm going to take the ln of both sides. Okay, not 3, not 2, but 3. And then just like before, because it's an e, it cancels, right? If this was like 2, we would bring it out front and do what we did before. But the L and the E are nice because they cancel out and it leaves you with 0.023x equals ln of 3. I'm going to divide by 0.023. And I get x equals ln of 3 over 0.023. And then I'm going to round it to like 4 or 5 decimal places. I just don't like that they do 2. That's ridiculous. 0.023. 47.76. We'll do 7658. How about that? Yeah, how about that? Sounds good. 47.7658. Okay. Now I'm going to check this just to make sure I'm right. So I've got to go back to the very original equation. So 200 e to the 0.023 times this 47. I'll say dot 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 and put it in the calculator. We want to see, is this close to 600? So let's say 200 e to the 0.023 times 47.7658. Oh yeah, 600.0006668. Yeah, that's close enough. That checks out. So that means that's our approximation. This would be our exact. Okay. This would be our approximation. This would be our exact answer. questions, comments, concerns before we kick it up just a little bit? Not that we're going to kick it up. We're going to solve for logarithms now. This is solving for exponentials, right? I mean, we've got exponentials going on. Our x value or our domain value has been in the exponent. Well, now what if our variable is inside the logarithm? What do we need to do? Okay. Well, again, there's a few basic things we can do. The first one, again, is if we have a nice setup, okay? And it's where you just have to turn the logarithm into an exponential. I'm going to make sure I'm in the right spot. Yeah. So let's say, I'm going to show you with an example here. Let's say we had log base 4 of x plus 3 equals 2. Notice we have a logarithmic equation now. I got an equation, has a logarithm. No example so far up to this has had that, right? And let's say we want to actually solve for the x's in here. Now we have to be careful because remember at the very end of last lecture, I said we could not have a negative value inside a logarithm. So we have to make sure to check our answers with logarithmic equations. We just have to. We might do everything correct and it wind up being a no solution. Okay, so we have to check our answers. So the easy way to do this is you set it up like a logarithmic equation and then just turn it into an exponential. Look, 4 squared equals x plus 3. Remember how to do that? All we do is just write this as an exponential equation. There's the base, there's the exponent, and that's what it's going to be equal to. And then we just solve it out. 4 squared, 16. We subtract the 3. 16 minus 3 is what, 13? So we think this is the answer. We're going to check it, but we think that that's the answer. So all we did was write our logarithmic equation as an exponential equation. Okay, that's it. And man, it's really easy when you can do it like this. Okay. And we'll see. It's not that we can't do it like that. For other equations, it'll take more steps to get it into a nice logarithmic once we get there. But let's check this now. Okay, so we're going to check it. So I'm going to say log base 4 of 13 plus 3, and I want to know, is that equal to 2, right? Well, this is log base 4 of 16. Is that equal to 2? Well, I'm going to put that in my calculator. I'm going to say, clear this out. Remember, log base 4 of 16, that's ln of 16 divided by ln of 4. Oh, yeah, that just winds up being 2. That checks out. So this is our solution, okay? That is our solution. Questions on this one?
Could you just do that last little part of that again for me real quick?
Which, are you talking about checking it?
The checking it part, yes.
Yeah, okay, all I did was plug in 13, right? 13 plus 3 gives me 16. And then I wrote log base 4 of 16 in my calculator. Remember, this is the change of base formula. That said, log base 4 of 16 is ln of 16 divided by ln of 4.
Okay.
And it equal to. Does that make sense?
Yes.
Okay, good.
Sorry.
No, you're fine. I'm glad you asked me. Trust me. Let's do another one, and I want you to do this, where all you have to do is turn the logarithmic equation into an exponential and solve it. Let me steal one. This is like number 56. Number 56. 56 says log base 2 of x plus 50 equals 5. So try this one. So I want you to solve this. Just pop it, write it as an exponent, and then solve it out. And then check it when you get done. Just check it. Check it when you get done. try this one. So again, I can write this as a logarithm, right? The base is 2. We'd raise it to the 5th power, and it's going to equal x plus 50. Now, 2 to the 5th is 35. You can pop that in your calculator and find out. I'm not 35. Good Lord. 32. You can pop that in your calculator. You'll see that. Now I'm going to subtract the 50. And I would wind up with negative 18, right? I hope it's negative 18. I'm going to check it, but I hope it's negative 18. So I'm going to check it underneath here. So I'm going to go back to the original equation, log base 2 of negative 18 plus 50. And I want to know, is that equal to 5, right? So log base 2 of 32. Oh, yeah, that's equal to 5. 2 to the 5th is 32. Now, if you wanted to check that in your calculator, though, you could say ln of 32 divided by ln of 2, right? That gives me 5. That checks out. Therefore, x equals negative 18. It's got to be the answer, okay? Has to be the solution. Got it? Okay? Questions? I'm going to kick it up a little bit.
So it didn't matter that that was a negative as long as you don't end up with a negative number in the parentheses.
Oh, yeah. It's whenever, let's say we were checking it right here, and when we added these, we got a negative. That's when we'd have to kick it out.
Okay, just making sure.
Yeah, no, it's a great question. It's a great question. Okay, hold on. I gotta get some paper. Okay, what if we have separate logarithms? So, actually, no, before we get there, let's look at a few different ones. Let's say like 62 here. 62 says 6 ln of 2x equals 30. Okay, 6 ln of 2x equals 30. This is number 62 on page 490. So number 62 on page 490. Okay, just like exponents, we need the ln by itself. So the very first thing I've got to do is divide this 6 over. So it would be ln of 2x equals 5. Okay, ln of 2x equals 5. And now, look, there's a few ways to do this, but we can do it with the exact same, in the exact same steps from before. We just have to realize that ln is really log base e. You don't have to write this down, but if you don't remember, ln is just log base e. This is where I'm getting it from. So now I'm going to write this as an exponent, and it would be e to the 5th equals 2x. Okay? E to the 5th equals 2x. That's where it's coming from. And then I've just got to solve it out. So I got to divide by 2. So I get e to the 5th divided by 2 equals x. Now, if I want a decimal approximation, this would be e to the 5th. Now make sure I come out of the make sure I'm out of the exponent when I do divide by 2. And I wind up with 74.2066. Okay, if I round it. 74.20. And I'm going to check it. Remember, this was the original equation here. So I'll use another color just to show. So I'm going to say 6 ln 2 times this answer. I'm going to show that it should be really close to 30. So 6 ln 2 times 74.2066. Oh, yeah, 30.000. That's really close to 30. So that means this would be, now, this would be the exact answer. This would be the approximate answer, right? That would be the approximate answer. Okay. And again, if it's multiple choice, you got to see which one they're using. But if you're checking it at the house, they might have either way in the back of the book. Okay. Okay, let's kick it up now. let's see. Ooh, yeah, 68 here. Log base 6 of x plus 5 plus log base 6 of x equals 2. What? There's two logarithms. And it wouldn't matter if I put this on the other side, it's not gonna be like a log equals a log because there's a 2 there. Whew, we got to go back into our bag of tricks from the last section before we can start solving this one. Okay. So I've got to go back into my last section, 4.3, into different examples to simplifying, actually condensing. Because look, notice both of these have a base 6. So I'm going to condense this down into one logarithm before I turn it into an exponent. I'm going to tell you, there's going to be a question like this on the test. It's going to be very similar to that. So I would really put on my listening ears right now. Hold on a second. So let's combine this. So we've got log base 6. Remember, if you combine them, you're multiplying it, right? So I'm going to put a big bracket here. X plus 5 times x. That's a 2. I don't know why I wanted to write it as a different number. And now I'm going to distribute the x. So I wind up with log base 6 of x squared plus 5x equals 2. Okay? Questions about that? That was 4.3 stuff, right? Remember, you combine, if it was addition on the outside of the same logarithm, you can combine it on the inside with multiplication. Not too crazy. Okay, so now I'm going to write it as an exponent. Well, this is our base, so 6 squared equals x squared plus 5x. Great. Now 6 squared is just 36, right? Nope, not 32. Oh man, this turns into an equation that we've been solving since day 1 of college algebra. This is a quadratic equation. We know how to do these, hopefully. So let's see if this thing factors. So if I wanted to solve this, remember, I've got to get everything on one side. So subtract 36. And I get 0 equals x squared plus 5x minus 36. I'm going to write it up here. This will factor, right? So 0 equals x plus 9, x minus 4, multiplies to give me 36, negative 36, adds to give me a positive 5. Set each one of those equal to 0. And I'll wind up with 2 answers, which is fine. We might have 2 answers, okay? We've got to check it. I'm not worried about that yet. I'm going to see if you have any questions, though. So we condense the logarithm, turn this into an exponent. So that's 6 squared equals this little binomial. Oh, look, this is a quadratic equation. 6 squared is 36, right? This is a quadratic equation. I got to get 0 on one side, factor the non-zero side, set each factor equal to 0. We've done that a lot this semester, right? Now I've got to check both of these, and we've got to check them separately. Okay, I've got to check both of them, and I have to check them separately. So I'm going to be a little lazy here, and I'm going to put another piece of paper on top so I can have the original equation. Remember, it was negative 9 and 4. Okay, negative 9 and 4. So I'm going to pop negative 9 in, so I get log of 6 of negative 9 plus 5 plus log of 6 of negative 9. Does that equal 2? Oh, I can just throw this one out right now. There's no way I could have a negative inside a logarithm. This creates 2 negatives inside logarithms, right? You guys see that? Look, does not matter. I know if you add them, you multiply them, it gets positive, doesn't matter. Because when I check this, when I put negative 9 in, it created a negative. inside, it could be either one, okay? But it created a negative inside a logarithm. I can just toss it out. Oh, I hope we don't toss out both of these. Which, I mean, we could have done everything right, and we just have to throw out both. But we're going to check the 4 too, okay? Log base 6, 4 plus 5, plus log base 6 of 4. Okay, yeah. Both of these work, right? We neither one create a negative. Oop. Log base 6 of 9, if I can add correctly, equals log base 6 of 4. Now, if I want to check this, I can multiply these with the addition. I can condense it down, right? So this would be log base 6. 9 times 4 is 36. Oh, look, this is a true equation. 6 squared equals 36. It works out, right? I'm going to just check it here. Because 6 squared equals, if I want to write this as an exponent, 6 squared equals 36. It checks out. So I know x equals 4 is a solution. So that's a lot of work there. But x equals 4 is a solution. It took almost as much time to check it as it did to solve it. But on these, you have to check them. Because one of them we did this correctly, but it's just not part of its domain. That's what it's kind of called. Not part of its domain. Okay. Questions before I keep rocking and rolling. We've lost everybody. This must not have been as.
I'm here.
You are here. You, Jen, and
just taking it in. Just taking it all in, man.
And I'm telling you, Chastity, it is okay if you don't grasp this right now. The beginning, this homework does a really good job of kind of spoon feeding you into the harder stuff. So there's no way you'll get here without doing the stuff before it. Okay. But
I know, I got you. And just quick question. I know I can go back and check and see, but this next test number 5 is strictly going to be over this stuff, right? This stuff.
4.2, 4.3, and 4.4.
Okay, gotcha. Okay, that's cool.
Yeah, no problem. Okay, we've only got a few more minutes, but I want to get some real applications in because there's some neat stuff in this application section. First, it goes over interest rates. I'm going to kind of zoom a little bit through this, so you can always come back and watch it. But I just don't have much time left. First, it talks about that compound interest formula. Remember, we had A equals P. This was for the non-continuous. We'll do a non-continuous example. Let's say we were given, which would be nice, $4,000. And the bank that we're going to invest in tells us you can make 7.5%. That'll never happen. At a bank anyway. And it's compounded, let's say annually, because I don't think we've done an annually example. If it's annually, it just means it's compounded once. And when we go to this bank, we really want to turn this $4,000 into $10,000. Okay? We've got a goal to save up to $10,000, and what we want to know is how long we have to leave it in the bank for it to get there. Okay, so the question's different for this section. It's not, just plugging it all in to see what we have after it compounds. We want to know, hey, if we've got $4,000, we got an interest rate, we know how often it's compounded. I want to know how long it's going to take. So the question is going to be the length of time, how long it's going to take to get us to a certain amount. So let's plug in what we know. We know, I'll do it over here, 10,000 equals, now our principal is 4,000. 1 plus, R is point, remember we got to write it as a decimal. Oh, crap, I ran out of room. Now it's divided by 1. We don't have to worry about it if it's divided by 1. Raised to the 1 times t, so that's just t, okay? Because n is 1, we don't have to worry about dividing by 1 or multiplying by 1. So let's write this out. Let's kind of simplify it out a little bit. 10,000 times 4,000 or equals 4,000. Now 1 plus 0.075 is just 1.075 raised to the t power. Okay. So this turns into a solving exponential equation, right? Our exponent is unknown and we've got to solve for it. So now we just went over logarithms. We got to switch back to solving for exponentials. And remember, if you solve for exponentials, the first thing you're going to do is divide this coefficient away. Now, 10,000 divided by 4,000, I believe, is 2.5. You can check me on that. If you want, okay? But 10,000 divided by 4,000 is 2.5. And now remember, once we had the exponent isolated, or the exponential term isolated, we took the ln of both sides. Okay? And then once we had took the ln of both sides, we could bring the t out to the front. Okay? And then now I've just got to divide ln of 1.075 on both sides. This goes away. And it leaves us with our t. Now, for this one, I am going to get a decimal approximation, okay? I'm going to get a decimal approximation. So ln of 2.5 divided by ln of 1.075. Oh, 12.66 years. 67. That's not too bad. So if I get an interest rate of 7.5%, it only takes almost 12 and a quarter year, 3/4 years to get it to turn into $10,000. That's not bad at all. Okay? Not bad at all. I know I'm zooming. It's because I want to get to one more example. We've only got 5 more minutes. You can come back and watch that. Sorry about having the zoom here at the end. Usually this section doesn't take as long to go over. Let's look at one more. Let's say there was something about, yes, number 117. We've got this function. This one always interests me. It says the function p of x equals 95 minus 30 log 2x, log base 2 of x, models the percent of students who could recall the important features from a classroom lecture as a function of time, where x equals days after the lecture. And you know, p of x is the percent of students that remembered. What is it? Yeah, students who recall. Percent of students that could recall the lecture, the important stuff. And it gives you a graph of it actually at the bottom of page 491. This is number 117 and 118. So the question states, how many days after, this is 118, let's do 118, because you can do 117 in the homework. 118, how many days have all students forgotten the important features of the lecture? Okay, so 118, it says, hint, let p of x equal 0 and solve for x. So how many days will it take for nobody? So p of x equals 0. No one remembers the lecture. Now we're going to plug that in. So we get 0 equals 95 minus 30 log base 2 of x. Okay, now this looks more like what we have been doing. Okay, and now we've got to solve for x. Now remember, with logarithms, you want to get it to where the log equals some number, and then we can just put it into exponential form. So I'm going to do that. First, I've got to just subtract the 95. So I get negative 95 equals negative 30 log base 2 of x, right? And then I'm going to divide by negative 30. Let's see what 95 divided by 30 is. If it's just some nice number, I don't think it is. No, it's not. It's 3.16 repeating. So I'm going to simplify it. Math, fraction. It's 19 over 6. Equals, now we've got log base 2 of x, right? Because this canceled. So 95 over 30 is just 19 over 6. So equals log base 2 of x. Now I'm going to solve for x. Now remember, at this point, all we have to do is write it as an exponent. 2 to the 19/6 equals x. That's going to be our answer. So 2 raised to the 19/6 is 8.9797 days. Oh, this is days, right? So look, by 9 days, I think it tells us to round maybe to the whole number. So after 9 days, everyone in the class will forget everything I talk about in this lecture. I always think that's interesting. Okay, I don't know how true it is. I don't know what exactly they did to get all that, but it's an interesting real world example. And I'm sorry I had to zoom through it. We're like pretty much out of class. For homework, starts on page 489. So this is 4.4. 489. I want you to do 1 through 41. These are going to be all odd. And then 49 through 69. I'm going to see if I can find another one I like in that section. 87 is a good one. Yeah, that'd work. And then some real world, some application questions, 103 through 119 odd. So all of these are odd.